Imagine a towering skyscraper, once a symbol of progress and ambition, now standing silent and empty. With a deep rumble and a cloud of dust, it collapses inward upon itself, transforming into a pile of rubble in a matter of seconds. This is the dramatic spectacle of building implosion, a carefully orchestrated demolition technique that has become synonymous with the rapid disappearance of structures from the urban landscape. Implosion, in its purest form, is a controlled use of explosives to break the support structure of a building, causing it to fall inward under its own weight. This technique has evolved over decades from a crude and dangerous practice to a highly specialized engineering feat. It requires a unique blend of science, experience, and meticulous planning to ensure both safety and efficiency. The use of implosion in demolition offers a number of advantages over traditional methods like wrecking ball demolition. These include speed, safety, and the ability to bring down structures in densely populated areas with minimal impact on surrounding buildings. However, the decision to implode a building is not taken lightly. It involves a complex assessment of factors such as the building's structure, its surroundings, and the potential environmental impact. The history of building implosion is intertwined with the development of explosives themselves. Early attempts at demolition often involved large quantities of dynamite, resulting in unpredictable and often dangerous outcomes. One of the earliest recorded uses of explosives for building demolition took place in 1852 in Rochester, New York, where black powder was used to demolish a church steeple. The early 20th century saw the rise of specialized demolition companies who began to develop more sophisticated techniques and safety protocols. One pioneering figure was Jacques Loiseau, who founded Controlled Demolition, Inc. in 1947. Loiseau and his company played a crucial role in refining implosion techniques, introducing innovations such as linear-shaped charges and precise timing mechanisms. The use of shaped charges, which focus the explosive force in a specific direction, revolutionized the field of implosion. These charges, often made of copper or aluminum, are carefully placed on the building's structural supports, allowing engineers to control the direction and sequence of the collapse with remarkable accuracy. Over the years, the science of implosion has continued to advance, driven by factors such as the need for greater precision, the development of new explosives, and a growing awareness of environmental concerns. At its core, building implosion is a carefully orchestrated dance between gravity, energy, and structural weaknesses. The goal is to use the minimum amount of explosives necessary to create a chain reaction of failures within the building's support system, allowing gravity to do the rest. The process begins with a thorough structural analysis of the building, identifying its load-bearing columns, beams, and other key elements. Engineers use this information to determine the precise placement and type of explosives needed to weaken these supports. The explosives used in implosion are typically high-velocity agents, which detonate rapidly, creating a powerful shock wave. This shock wave, combined with the expanding gases released by the explosion, creates a localized pressure exceeding the strength of the concrete or steel supports. As the supports fail, the building's weight shifts, transferring the load to the remaining supports. This process continues in a carefully planned sequence, with each successive failure further destabilizing the structure until it can no longer support its own weight. The success of an implosion demolition relies heavily on meticulous planning and a deep understanding of both engineering principles and the specific characteristics of the building being demolished. The process typically begins months in advance with a site visit and a thorough assessment of the structure. Engineers create detailed blueprints of the building, marking the location of every explosive charge, the timing sequence for each detonation, and the anticipated fall pattern of the debris. Computer modeling and simulations are often employed to predict the collapse dynamics and ensure that the implosion will proceed as planned. Safety is paramount in every stage of the implosion process. Exclusion zones are established around the demolition site, and strict protocols are followed to evacuate residents, secure surrounding buildings, and protect the public from potential hazards such as flying debris and dust. The implosion team consists of highly skilled professionals including blasters, demolition experts, and safety personnel. These individuals work closely together to ensure that the demolition is carried out with the utmost precision and adherence to safety regulations. Section 5. Notable implosions, American landmarks reduced to dust. Iconic demolitions in the U.S. have captured the public imagination. Often televised, these events showcase the power and precision of demolition. The Seattle Kingdom's implosion in 2000 was a notable event. The massive dome was brought down in seconds, creating a cloud of dust. The Sands Hotel in Las Vegas was demolished in 1996. It made way for the Venetian Resort, witnessed by thousands. The Georgia Dome's implosion in 2017 showcased advanced demolition technology. The dome was brought down in a controlled implosion lasting 12 seconds. Section 6. The human element, expertise and the buster. The science and engineering behind building implosion are impressive, but the human element is crucial. Demolition experts possess unique expertise and understand the risks involved. The blaster is responsible for the safe and effective use of explosives. They handle everything from site assessment to final inspection. Teamwork and meticulous attention to detail are paramount. Ethical considerations are also involved in demolishing significant structures. Section 7. Environmental concerns, dust, debris, and mitigation. Implosion offers rapid demolition but raises concerns about dust, debris, and hazardous materials. The industry has developed strategies to address these concerns. Techniques like misting systems capture dust particles. Debris is sorted for recycling and disposal. Hazardous materials are removed according to regulations. Companies work with authorities to minimize environmental impact. Section 8. The future of implosion, innovations and challenges. The field of building implosion evolves with technological advancements and environmental concerns. Innovations promise more precise, efficient, and eco-friendly implosions. Digital detonators offer greater accuracy and control. They allow for a more controlled and predictable collapse. Robotics in demolition is another promising development. Remote-controlled machines reduce reliance on explosives. However, urban density poses challenges for implosion. Environmental concerns will shape the future of implosion. Section 9. The enduring allure, why implosion captivates us. Despite the inherent risks and environmental concerns, building implosion continues to captivate the public imagination. There's something undeniably mesmerizing about watching a massive structure crumble into a pile of rubble in a matter of seconds. But what is it about implosion that holds such allure? Perhaps it's the sheer spectacle of it all. The sight of a building, once a symbol of permanence and strength, collapsing inward upon itself is a powerful reminder of the impermanence of our built environment. Or maybe it's the element of controlled chaos that implosion represents. The idea that something so destructive can be orchestrated with such precision is both fascinating and awe-inspiring. Whatever the reason, there's no denying that building implosion holds a unique place in our collective consciousness. It's a testament to human ingenuity, engineering prowess, and our ongoing fascination with the forces of creation and destruction. Section 10. Conclusion, a blend of art and science. Building implosion is a fascinating blend of art and science, a testament to human ingenuity and our ability to harness powerful forces for controlled demolition. From its early days of unpredictable dynamite blasts to today's sophisticated use of shaped charges and digital detonators, implosion has evolved into a highly specialized field that demands both technical expertise and a deep respect for safety and the environment. As we look to the future, we can expect to see continued innovation in implosion techniques, driven by the need for greater precision, environmental responsibility, and the challenges of demolishing structures in increasingly dense urban environments. Despite these challenges, one thing remains certain. The spectacle of building implosion, with its unique blend of power and precision, will continue to captivate our imagination for generations to come.